Use transformations to graph the function y is equal to 1 over x plus 1 minus 2. The first thing that we need to do is to identify a parent function, or the original function that can be transformed to get the graph that we're looking for. And the reciprocal function is the parent function here, and it's being both shifted to the left 1 unit and down 2 units. This plus 1 is considered to be on the inside because it's in the same position as the x. It's receiving the same action as the x. It's in the denominator. This minus 2 is considered to be on the outside. Any of the inside transformations are horizontal transformations and backwards from logic. So a plus 1 is going to take this graph to the left 1. Any of the outside transformations are going to affect the graph vertically, and they go in a logical direction. So again, we'll say this plus 1 is going to take the graph to the left 1, and this minus 2 is going to take the graph down 2. Let's be reminded what the reciprocal function looks like before any transformations occur. This is the one that has two asymptotes, a horizontal asymptote at y is equal to 0 and a vertical asymptote at x is equal to 0. We also have 2 points of interest, 1, 1 and -1, -1, that we need to keep track of as we move through our transformations. And in this example, we'll keep track of those points of interest on the graph, but also in a table. So we're just going to list those points of interest, 1, 1, -1, -1, and the two asymptotes are also going to be considered points of interest. We're going to want to keep track of where those land as well. So remember, we're going to be shifting to the left 1 and shifting down 2. And if the only transformations are shifts, we can do it in any order. Let's begin with the left 1 shift. When we shift left 1, we're going to shift all of the points of interest to the left. So our 1, 1 ordered pair goes to the left 1 unit and lands at 0, 1. The -1, -1 ordered pair moves to the left 1 unit and lands at -2, -1. The vertical asymptote is also going to go to the left 1 unit, and that's now going to land at x is equal to -1. In theory, we move the horizontal asymptote to the left 1 as well, but that's not going to change the position of that horizontal asymptote. It's still located at y is equal to 0. Now we'll connect the dots and approach those two asymptotes. Again, remember, in the reciprocal function, we do not actually arrive at the asymptotes. We're going to get close to them, but not actually touch them. In a more challenging problem, it might be easier to find our points of interest on this table. So the action that we just took was moving the reciprocal function to the left 1 unit. And when we do that, we operate on the x values of the ordered pairs in a backwards from logic way. So it looks like we might be adding 1 to the x values based on what we see in the function, but we're actually going to be subtracting 1 from the x values. Any inside operation or horizontal operation is going to be backwards from what our logic might tell us to do. When we operate on an x coordinate, we're not going to do anything to the y values. So point by point here, we're going to subtract 1 from the x and no change to the y. 1 minus 1 is 0, no change to the y coordinate. Again, subtract 1 from the x, -1 minus 1 is -2, no change to the y coordinate. Since this is an x value, we are going to subtract 1 from the x and get x is equal to -1. But y is equal to 0 is not an x coordinate. We don't change the y coordinates, so this is just a copy-paste because there's no changes to the y in this step. Let's stay with the table for our next transformation. Continuing from where we left off, the next thing that we want to do is the -2 on the outside. And this outside transformation is going to affect the y coordinates of the ordered pairs in a logical way. So we see a -2 out here, and that's exactly what we're going to do to the y values. We're going to subtract 2 from the y coordinates of these ordered pairs. And when we do that, we're not going to change the x coordinates at all. So we start with this ordered pair, no change to the x, -2 from the y, so we'd get 1 minus 2, which is -1. No change to the x, so that's going to stay -2. -2 from the y is going to be -3. Again, no change to the x, so this asymptote, since it's an x value, doesn't change. But this asymptote, since it's a y coordinate, we are going to subtract 2 from the y, and it's going to move down to y is equal to -2. So these are going to be the new points of interest on our final answer graph. If we perform the transformation graphically, we would be starting with the 1 over x plus 1 graph and moving each of these ordered pairs down 2 units. So 0, 1 would go down 2 and land at 0, negative 1. Negative 2, negative 1 also goes down 2 and lands at negative 2, negative 3. Y is equal to 0 goes down 2 and lands at y is equal to negative 2. And in theory, x is equal to negative 1 also goes down 2, but when a vertical asymptote is shifted down 1, it doesn't change its position. So now we connect these dots by approaching the asymptotes, passing through these points of interest, and then approach the horizontal asymptote. Again, we get infinitely close to the asymptotes, but we never actually arrive there. Approach the asymptote, pass through the point of interest, and approach the asymptote. And this would be our final answer with clearly labeled points of interest and clearly labeled asymptotes, which meets the directions requirement.